Today's lesson, 14.2, polygons in the coordinate plane. Our essential question, how can you solve problems by drawing polygons in the coordinate plane? So today's lesson is going to combine a couple of things we've been working on. The distance formula from the last couple of days, finding lengths of sides, and then we are going to be plotting points and making polygons, which we looked at last week, and then finding area. All right, so quick vocabulary. A polygon is a closed plane figure formed by three or more line segments that meet at their endpoints. A vertex is a point where two sides of the polygon meet. All right, so the vertices of a polygon can be represented as ordered pairs. So that's what you're going to see here. All right, so we're going to plot these points to form one of the tile shapes. So these are vertices right here for each of these letters. So remember the difference. First letter is across, second letter is up and down. All right, so very quickly, point A, I'm going over 3 up 5. Point B, I'm going over 4 up 6. C, I have over 5 up 5. And then lastly, over 4 up 4 for D. Connect my dots. And I have a four-sided equal side figure, which is a square. And it looks like a diamond there, the way it's rotated. All right, going down now to B. I am going to plot these points. So now I have negative numbers, which means I started at the origins and I go to the left. So P to the 5 to the left, up 2. R negative 4, up 3. R over 0, up 3. So that starts at the origin, okay? Up 3. S over 1, up 2. T over 1, negative 2. U over 0, negative 3, so straight down 3. V to the left 4, down 3. And then lastly, W to the left 5, down 2. All right, so what I'm going to do now is I'm going to connect my points. I'm going to ignore the origin because that's what I use as a starting point. All right, so it wasn't one of my points in my shape. So there are my vertices. I'm connecting them. Now it asks me to describe the polygon. So what do I have? 1, 2, 3, 4, 5, 6, 7, 8 sides. 8-sided polygon is known as an octagon. All right, has that prefix oct at the beginning. Octopus, octave in music is 8 notes. All right, so now I'm going to go down here, look at my question. How is the number of vertices related to the number of sides on a polygon? So let's just take a look. A square had 1, 2, 3, 4 vertices. Octagon had the 8 points there. So the number of vertices, the number of coordinate points will equal the number of sides. That's what they want you to connect to. All right, so here we go. Next type of problem is going to be finding perimeter in the coordinate plane. If you remember perimeter is distance around a shape. All right, so this is the type of problem you'll see here. We did one like this a couple chapters ago. The grid shows the path Tommy followed when he walked from his home at 0, 0 to various locations and back home again. All right, so take a look here. He started at home. Where's my marker? He started home here at the origin, and then he went to the library, over 0, up 4, so the library is here. Then he went over to the park, down to his friend's house, over to the pond, down to the store, and then back home again. All right, so to find the distance, what we're going to do is find the distance of all these lines for our perimeter. All right, so let's just take a look. What is our scale again? It looks like we're counting by ones, right? So that's going to make it easy for our units. Instead of using absolutes, just count the number of jumps from one to the next, right? And use your axis to help you now, all right? Some of you guys are having problems. You were mixing up the numbers yesterday between X and Y. Always look at your starting point. You're going here from 0 to 4, all right? So that has a distance of 4. Here, I'm going from 0 to this number here. Let's take a look at that. That's 5 across on the bottom. So that means it's going to go from 0 to 5. Distance of 5. So here we go from down to here. That's 2. From here to here, we have 2. Here to here, we have 2. Now look at my point. I have 7. Now I'm going back to the origin at 0. Now I have 7 here. So I'm going to add all my numbers together. All right. I have 5, 4, 3 2s, and a 7. All right, so depending on how you do that, I'm just looking at this right away. I have 6 here. 6 goes with 4 to get to 10. Plus 5 is 15. Plus 7 is 22. So his perimeter, his walk was 22 blocks around. All right, so that's how you use distance formula to find perimeter. All right, I'm going to clear this and we'll go on here. All right. So now finding area in the coordinate plane. All right, so this one is done for you. Notice how the vertices have already been plotted. So we are going to find the area now of Caleb's new deck. All right, so take a look down below. You see how they're using absolute values. So that is, again, a method that you can use if you understand that. But let's take a look. All right, so we have the area of a rectangle. And that, again, was the area equals the base times height, or also known as the length times the width. All right, so let's find that. Let's find the length of our base. So we're going here from C to D. All right, so let's take a look here. C is at 3. D is at 8. So you subtract. 8 minus 3 is 5. You could have also counted. All right, some of you guys are like double counting or missing counting when you're counting. So take a look if you did the counting approach. 1, 2, 3, 4, 5. All right, now we're going from D to E. All right, if we're going to use the axis to help us, take a look. That's 5. And then now down to B is 2. All right, so 5 minus 2 is 3. All right, so now I have my 4 sides. I could find the perimeter if I needed to, but they're asking me for area. So here we go. I'm going to plug it in. The area of my base is 5 times the area of my height is 3. So I have 15. And what is it giving me for units? So 1 foot. All right, so I have square feet. I put SQ feet. Could also put FT and the little 2 for square feet. All right, so that's how you use your coordinates to find the area. All right, and then we'll just do one more here, all right, because they want you to graph and then find its area. This is what you guys are going to have on your work, so I just want you to see one more example. So let's do it. L is over 1 up 2. M is over 1 up 6. N is over 7 up 6. O is over 7 up 2. And P is over 5 up 0. And then lastly, we have Q over 3 up 0. All right, so what I'm going to do is I am going to make my shape. Should look familiar on the bottom there, right? All right, looks like we have a trapezoid. All right, so what I'm going to do first is I'm going to do my rectangle. So I have my rectangle here, and then I'm going to do my trapezoid. All right, so remember the two formulas. So the area of the trapezoid was 1/2 base 1 plus base 2 times the height of the shape. Okay, so we'll come back to that. We're going to do the area of the rectangle first. All right, so let's do that. So take a look at my starting point and ending point. All right, I can go straight down now. That's a 7, and this is a 1. So I'm going to subtract. I can also count over, but let's use the axis. That's why it's there. So 7 minus 1 is 6. Here, I'm going from 6 down to 2. So 6 minus 2 is 4. And then I have my 2 sides, right, that I can fill in. Opposite sides of the rectangle are the same. Area of my rectangle, base times my height, is 24. All right, so now I need to find my trapezoid bases. All right, so I already have the first base on top there is 6. Now I look down below. What is my second base? I'm going over from 3 to 5, and hopefully you can just see, you can count that. Now I'm going to plug in those numbers here. All right, so I have 6 plus 2 on the inside. So I have 1/2. 6 plus 2 parentheses is 8, right? Times the height. What is the height of my shape now? Take a look. The height is from there to there. The height from base 1 to base 2, that is also a 2. So now I'm going to times. All right, 1/2, 8 is 4, times 2 is 8. All right, so my trapezoid is 8. My rectangle is 24. I'm going to add the 2 together. I have 32 squares. All right, so that is how we use our concepts to do this. All right, so just want you guys to take a look at the homework. I took a combination of different problems and I put it together. All right, so you're going to be practicing everything we just did. All right, so I'm not sure if I'm going to be able to use, there we go. I can use this marker here. All right, so word problem. All right, gardener uses a coordinate grid to design a new garden. You're going to plot the points first. All right, follow the directions. How much fencing will they need? All right, so answer those. What is the area of the garden? When they talk about fencing to enclose, that's distance around, so that's the perimeter. So do the perimeter first, okay? And then when they ask you area, that's multiplying base times the higher, depending on what your shape is. All right, so for the next two, find the shape to the right, find the perimeter, and then find the area. All right, so label the sides. All right, the distance is there. And then lastly, for the shape above, find the perimeter. All right, so there's a couple different ways you could do that. You could cut it this way if you wanted to, or just going to erase that for a second. I'm going to go the opposite way, go straight down. All right, so however you look at it, you're going to have two rectangles. All right, so find the first of all, the perimeter, distance around. You don't have to cut it into rectangles to do that. You just find the distances of all the sides going around. And then lastly, for the area, you have to cut it into the rectangles. All right. So any questions, let me know. Pretty straightforward lesson today. Use your coordinates to find a polygon, find its perimeter and area.